currently have a positivity rate of 12%. So that means that 12% of all COVID tests that were analyzed were positive. We select 10 tests at random, find each of the following. Okay. So what is the probability that the first positive test is on the 6th test selected? Positive p equal to. What's the probability that a test turns positive? Turns up positive. 4%, right? Is that given to us? What's the failure probability? What's the probability Q that the test comes back negative or not positive? 88%. 1 minus p. We'll use this same formula from the backboard. Q to the x minus 1 times p. So we're going to have 5 straight failures to start this probability. We're going to have 5 straight negative tests. And then what happens on the 6th one? You get a positive. Start with 5 straight negatives, then you have your positive test. So the geometric test to the 5th times 0.12 is about 6.33%. Right. Let's see here. We're going to look at 10 randomly selected tests. Of those 10 randomly selected tests, that there are positive tests within that group of 10. What does that mean? We've got that right. So it could be 1 or higher, 1 through 10, right? I have at least 1 positive test in the set of 10 randomly selected. I don't want to go through 1 positive, 2 random tests turn up positive, 3 random tests turn up positive.
1 minus no positive test.
Okay. Let's try that. 1 minus no positives. Like Joey said, some positive tests means at least 1 of them was positive. Is it the opposite of at least 1? None? So let's take the one that we don't want to have as a part of our value away from 100%. No positives. 12% are positive, so 88% are not positive or negative. I need all 10 to not be positive. So that about 72.15%. About a 72% chance that at least some of the 10 tests will turn out positive. Have some positives in this set of 10. 72% of the time. The first positive test is on the 3rd or 4th test selected. What do we do here? The first COVID test, rubber test picked or the fourth test picked? So I need to take the sum of those two outcomes, because can't it happen more than one different way? I could get the first positive test result with the third test I pick, or the fourth test. So add those two probabilities together. What's the probability that I get the first positive result on the third test chosen? What's the probability I get? It's either the third or the fourth test. So when I have an or statement like that, we combine the two probabilities together. If I get the first positive result on the third test, what happens on the first two I would have picked? Okay. So 88% are negative. That happens the first two times. And then the last result. Result. With the probability that you get the next positive result on the fourth test select. If I don't get a positive test result until the fourth test, I would have had a negative test for the first three tests chosen. 0.88 to the third times 0.12. So the first one's about 9.2, 9.3%. We're going to add that with the next one. 0.88 to the third. 0.12. Having the first positive result happen on either the third or fourth test picked, about 17.47%. So these first three are finding some probabilities. Let's look at finding the average number of tests before something happened and the standard deviation. What's the measure of center and spread in the geometric model? Average number of tests before the first positive result. The expected or average outcome in the geometric model is 1 over p. So I want to find the average number of tests before I find the first positive. I need to take 1 divided by p. What is p in this case? What is the chance of finding a positive test result? Say again? 12%. So take 1 divided by 12%. So on average, it's going to take about 8.33 tests before they find the first positive COVID test. Should take about 8.33 tests on average until finding the first positive test result. Average number of tests before the first negative result. You still use the same formula. The average of the geometric model is 1 over p. The average number of trials before the first success is equal to 1 over p. But what is p in this case? What's the chance that I have a negative result? 88%. I've changed how I describe success. Success on question 4 was finding a positive COVID test. For the next question, success by finding the negative test result. Since we're dividing by a larger number, this is going to be much smaller. It's not going to take as long to find a negative test compared to a positive test. Standard deviation. This is a random or 1.14 test till we find the first thing. Standard deviation of the geometric model. Square root of q divided by p squared using the same formulas from your notes from yesterday. We're talking about finding the first positive. What is the standard deviation and the average number of tests before the first positive is found? So we'll go back to using the p positive test result of 12%. Q, finding a negative test result, the opposite, 80. Plug those numbers in for p and q into your formula. Let's see what we got here. So, looks like it's going to be 88% divided by 12%. About 7.817. First positive is 8.33 and the standard deviation is 7.817. There's a lot of variability. So I would guess that we would find the first positive test anywhere between about 1 and 15 tests. You might not get the first positive until the 15th test sometimes. You might get the first positive test after only 1 or 2 tests selected some of the times. There's a lot of variability in this experiment, in this situation. Questions here? Let's try this. Why don't you go ahead and grab your laptops and we'll get on to Schoology. I want to have you guys try one particular question off of those